Okay, so now let us get to the next section that we talk about the derivative as a functions. Okay, now last section we actually will talk about the derivative. Okay, so for example, like in this case right here, if I have a number a, okay, so if I want to find the derivative f prime, again, if this is the function f, okay, then if I want to find f prime of a, is actually we are going to take the limit as h approaching to 0 f of a plus h minus f of a over h. Okay, so as you know that this is basically this is the different quotient. Is tell me that if I have the distance is h right here, then so therefore in this case I have this point, right? A plus h and f of a plus h. Okay. So basically what we are looking for is we are looking for the way of change between these 2 points. Okay, this is what we have, the different quotients. And then as h approaching to 0, then this is the idea that we find that this is actually is the slope of the tangent at x equal to a, right? So this is what we learned last sections. Now this section right here is a slightly different. We would like to have the derivative is depend on x, meaning what? Right now, I'm not going to fix the a. It could be anywhere, any number on the x-axis. Then, meaning to this one right here, basically the derivative has a function, okay? That function is depend on x. And you will see that to this one is really similar to the last section that, okay, we replace the x, the a by x. Okay, so therefore again, in this case right here, you will see that the function basically is actually is we have x right here, and then we are going to have the distance from here to here. So we have this point. So, okay, so of course to this one right here, we have x plus h, f of x plus h here, and then to this point right here, we have x, f of x, right? So again, we are looking for the different quotients between for the slope of the secant line here, okay? And we take the limit as h approaches to 0, then in this case, we got the derivative now. Okay. Now again, remember this derivative basically is talking about the slope of the tangent line, and that's when has a function of x then. Okay, so then here is that f prime of x represents the slope of the tangent line to the graph y equal to f of x at a point x f of x, or the instantaneous way of change of a function f at a point x f of a, f of x. Okay, okay. So right now I would like to talk about the notation now. Okay, so to the derivative. Okay, of course we know that if y equal to f of x, then sometimes we use f prime of x. Sometimes we work with y prime. We have dy dx, df dx, d dx of f of x. Now again, this is actually something that we use it in calculus. Okay, we often use them. Okay, and then we have d f of x, d sub x, f of x. This is sometimes we use it like physics. Then we like to use the notations. Okay, some physics textbook they are using this type of notations, where the simple d and d dx are called the differentiations operators. Okay, those are the operator because they indicate the operation of differentiations, which is the process of calculate a derivative then. Okay. Now, sometimes you will see that from time to time, I would like to use this notation right here, okay, for f prime of a. So it just say that dy dx evaluate at x equal to a. Okay, so this is the notation that I'm using. Okay, okay. So right now, then let's see, how do we use the definitions to take the derivative, okay, to find the f prime of x, and then at the end, we would like to find f prime of 4, okay. Now, to your first test, you should expect that I ask you some problem is actually related to this using definitions, okay, to take the derivative, okay. Now, how do we actually do this? Then, of course, if I want to find f prime of x, then I need to set it up. It will be the limit h approaching to 0 of f of x plus h minus f of x over h, okay? So this is how we set it up. And now, again, remember this is the f function now. Remember, when we work with the f function, basically is kind of like we depend on the input, right? So in this case right here, if I have f of x equal to 1 over x plus 1, that means this is my input right here. F of the input is equal to 1 over the input plus 1, okay? So basically, if I want to translate from the function notation to the expression, how do I do this? I will take the limit h approaching to 0 of, in this case right here, I will have 1 over x plus h plus 1 minus 1 over x plus 1 all over h, okay? So this is how we do this, okay? Okay, so again, the reason is we replace x, again, to the first expression, we replace x by x plus h then. And then now, how do we take care of this type of like fractions over a h, right? A number or fraction over a fractions. Now to me, I would like to work with like the LCD, okay? So now you will see that to this one, basically the LCD is x plus h plus 1 times x plus 1, right? So this is the LCD. So what I'm going to do here is I would like to multiply top and bottom by the LCD then. This is a way to clear the fraction. X plus h plus 1 times x plus 1, then over x plus h plus 1 times x plus 1, okay? Okay, and now we are going to, okay, again, we take the limits, right? Okay, so we will have this one times this whole thing. So you will see that x plus h plus 1 cancel. So I will have x plus 1. And then minus this one times this whole thing right here. Maybe let me make it better. Okay, so I will have this one multiplied to x plus h plus 1 times x plus 1, right? And then minus 1 over x plus 1 times x plus h plus 1 times x plus 1. This is the idea. And then all over h, x plus h plus 1 times x plus 1. Okay. And then now you will see that this one cancel. So I will have x plus 1 minus this one and this one cancel. X plus h plus 1 all over h. X plus h plus 1, x plus 1. Okay. Now, I found that a lot of students make the mistake here. They forgot to put a parenthesis. So in this case, it will mess up the whole, that's been a way to simplify the expressions, okay? Make sure that you put a parenthesis around because you subtract the whole thing. Right. And now, so I have x plus 1 minus x minus h minus 1. Okay. Okay, and then now we know that x minus x, 1 minus 1. So I have negative h left, right? Okay. And now you will see that h and h cancel. Then in this case, now I could direct substitution h equal to 0. So I will have negative 1 over x plus 1 times x plus 1. So which is negative 1 over x plus 1 to the square then. Okay. Okay, so then this is exactly what we have. And then now, of course, I need to find f prime of x and f prime of 4. So then in this case, I have f prime of x is equal to negative 1 over x plus 1 to the square. And f prime of 4 is negative 1 over 4 plus 1 to the square. So it's negative 1 over 25. Okay, so now you could actually pause the video and then try to see if you could take care of the B, okay? Okay, then let me show you the solution then. So I would like to find f prime of x is equal to the limit h approaching to 0 of square root of x plus h minus 3 minus, maybe let me set it up first. F of x plus h minus f of x over h, okay? Square root of x plus h minus 3 minus square root of x minus 3 over h, okay? Okay, now, remember, if you remember, okay, something that we learned in chapter 2, then if we have something like this, what we want to do is we are going to multiply the conjugate, okay, the conjugate pair. So what I need to do here is I would like to multiply square root of x plus h minus 3 plus square root of x minus 3 then. Okay, okay, and now I will have this one is the limit h approaching to 0 of, so I will have x plus h minus 3 minus x minus 3. Okay, then now I will have the limit h approaching to 0 of x plus h minus 3 minus x plus 3. Yeah. And now, of course, x minus x minus 3 plus 3, right? So I will have, so I have h over h square root of x plus h minus 3 plus x minus 3, okay? And now, of course, h and h cancel. So I have 1 over, again, I substitute h equal to 0 here. Then, of course, I will have 1 over 2 times square root of x minus 3 now, okay? Okay, then I have f prime of x is equal to 1 over 2 times square root of x minus 3. And f prime of 4 is 1 over 2 times 4 minus 3. And I got 1/2 then, okay? Okay, so then, now, of course, to this section right here, I only show you the 2 examples, but again, because again, the last section, I already showed you some other like polynomials and some other type of function. How do we actually find the derivative, right? Okay, so, and then now I have 2 more, okay. Okay, so again, to you, try to practice a couple more functions, okay? And then, yeah, and that's it for today, okay? Okay, see you next time then.